Hey guys, so this is all about how to understand the different quadratic forms and what it means about their graph. And so if you're looking at the homework tonight, we have 1 through 5, and you have a different form for 6 through 8. And then you have a third form, a different form, 9 through 12. So this is really going to try to tease out what is the difference between all three of these forms and what does it mean for the graph. So let's go back for a minute and review. Standard form is the A, B, and C version of a quadratic. This is where you use the quadratic formula if you're trying to see what makes it 0. This is what it looks like before you factor it a lot of times. And so that is standard form, and it can tell you a few different things. When A is a positive value, we know that it's facing up. And if it's a negative value, we know that that parabola is facing more down. And we also understand that the C value is your y-intercept. So for example, I just kind of made up one here, negative x squared plus 6x minus 7. The fact that this is negative would mean the graph is facing down. And I know that the y-intercept would be negative 7. Now if I want to know the vertex for this one, I really need to use this formula, negative b over 2a. So let's go to number 1, and let's identify the y-intercept. First of all, the y-intercept is always the C value in standard form. So that means I'm looking for 0, negative 3. And that should help us out with the graph because that means I have a point right here. Now, that's not necessarily the vertex. I would have to use negative b over 2a to know what value to plug in. That would also tell me where the center is and where that axis symmetry would cut through the graph. So if I'm looking at the problem, b is 2, so in the formula it's going to look like it's negative 2. A is 1, 2 times 1. So essentially I've got negative 2 divided by 2, which is negative 1. So that means that I'm going to have my graph cut in half when x is negative 1. And that also tells me that my vertex, x value, is negative 1. Now, we'd have to plug that value in to really know what the other value is. So let's take a moment to calculate what would negative 1 be if you plugged it into the equation. So I was having trouble with my board, so I went ahead and typed it in, me showing you plugging in negative 1 for x in both places. And when you do all that math, you end up getting negative 4. So negative 1, negative 4 is my vertex. Negative 1, negative 4. And what's great about understanding some of the patterns in terms of in graphing quadratics specifically, if you know you're at the bottom and there's this axis of symmetry that cuts it in half, well then that means that I know that I'm going to go up 1 over 1 for this point. Also know that I can go up 3 and over 1 for the next point, if the board will let me show you those points. See? And then we can connect those for our graph. Okay? So for doing standard form without a calculator in terms of graphing it, you really need to know that negative b over 2a kind of helps you get your center point. Okay. Now, is this a minimum or a maximum? Because it's at the very bottom, that vertex is at the very bottom, we're going to choose the minimum. Okay. Maximum is when that point is at the very top because a was negative, flipping the graph down. So how many zeros or x-intercepts are there for this quadratic? So x-intercepts means where does it cross the x-axis? And so if I look really closely, it looks like it crosses at 2 different points, this point and this point. And so if you look in the graph, that is 1, 0, and it's also negative 3, 0. Okay? So that finishes graphing standard form. Now as I look at the next one, this is called vertex form. This is what is in the middle here, what we've been talking about, h and k. And the values of where that turns around is actually just in the problem. But you need to understand that that first value is kind of messing with you. A lot of students don't understand that that sign is kind of changing a little bit because it's more about what makes that value bottom out or what makes it 0. So if I'm looking at this and I recognize it as vertex form, then I can really immediately know that it's 4, 3. 4 minus 4 would make that 0, maximizing yourself at 4, 3. And the fact that it's this negative out front tells me that when I go and find 4, 3, right 4 up 3, let's try to 1, 2, 3, 4, 1, 2, 3, right here. We need to be really conscious of the fact that we're going down in that odd pattern. If you're going to try to make this a little easier on yourself by going down 1 over 1 and down 3 over 1, just make sure that you notice that this is going in the negative direction. Okay, so I'm going to go down 1 over 1. I'm even going to go down 3 and over 1. And maybe if I have time and I want to do it because I want to show all my work, I can go down 5. 1, 2, 3, 4, 5. So once I get all those points there, we can go ahead and connect them because it's a continuous function, down forever. Domain's all real numbers, but it's all values less than 3 for the range because it only goes up to 3. Is this vertex a max or a minimum? It's a maximum. It is a maximum point that we would say that vertex peaks out at the top and then comes back down forever. So in terms of this last one, this is called factored form. So I want to go back for a moment to number 1 and show you something that's really important to understand. If I was to factor this standard form and change the way it's written into factored form, if you notice, what makes each of these 0 are these red points that I have on the graph. So for example, negative 3 plus 3 is 0. That's this x-intercept there. And 1 minus 1, well, that's this x-intercept there. So the point of factored form is to really help you understand where it hits that x-axis. So for example, if you had x plus 2 and x minus 3, that means it would cross at negative 2 as well as positive 3 on the x-axis. So that can kind of help us think about this last one a little bit. So if I'm thinking, well, what makes this 0? I would notice that, well, when x is 2, your output is 0. So 2, 0 is a point right here, sorry. And what makes the second one 0 is negative 4. If I go to negative 4, that would also make 0. So let's think about how we can figure out the rest of the graph without necessarily using a graphing calculator. So what I'm wanting to explore here is plugging in different numbers. And so I may plug in 1, for example. If I was to plug in 1, I would have 1 minus 2, which would be negative 1. And 1 plus 4 would be 5. And if you multiply those two together, you get negative 5. So that means in terms of making a little table, if I was to plug in 1, you're going to get out negative 5. So 1, negative 5 is a point right there. Well, let's plug in 0. 0 minus 2 would make negative 2. And 0 plus 4 would be 4. And negative 2 times 4 is negative 8. And that's my y-intercept right here. So I can start to see that U forming, and if you really pay close attention, this one goes up 3 and over 1, and this one goes up 5 and over 1. So that kind of tells me where I am in that pattern. So I can go down 1 and over 1 and kind of guess or assume that that's probably the vertex. And then I can start going back up. There's that matching symmetrical point. Up 3 and over 1, there's that symmetrical point. And then up 5, and now you have all the points. You can go up 7. 1, 2, 3, 4, 5, 6, 7 right there. There's another one. Now that's not the only way you could have done this. You may have decided, hey, I really don't want to plug in different points. I want to understand what it is in standard form. Okay? So x times x is x squared. X times 4 is 4x. Negative 2 now distributes to be negative 2x and negative 8. And then you have x squared plus 2x minus 8. And if you notice that negative 8, that's this y-intercept right here of negative 8. So that would tell me another point. But then if you're doing this, you're going to have to go back to that negative b over 2a to figure out where the center is. B is 2, so that really makes it negative 2. this 1 is the a value, so 2 times 1 is 2. And so when x is -1, that's when you're in the middle of the graph. That's where that axis of symmetry would be. That's where you're going to plug in -1 and you're going to get out -9, and that's the vertex point. So that's kind of doing the axis of symmetry part. X would have to equal -1 to put you in the middle. And that point that's at the very bottom of the vertex, which we would have a minimum in this case, would be -1, -9. Okay? So that's a little bit about the three forms. You know, standard form does its own thing. It can tell you if it's going up or going down. It can tell you where the y-intercept is. You need a little formula, -b/2a. Vertex form is all about finding that turnaround point, whether it's a max or whether it's a min, but the numbers are living inside the equation. You just kind of have to understand how to extract them or how to pull them out. And then factored form is all about understanding how can you see where it hits that x-axis, and it's what makes each of those factors 0. So this problem is really trying to get us to understand each equation is written in a certain way. For example, the first one is in standard form. The next one's in vertex form, and the last one is in factored form. Now, if you read the story, an archer standing on a platform shoots an arrow, and all of these model the same arrow's path, where x is the time the arrow's in the air, and f of x, or y, or the outcome, is really the height in that moment. So just a quick little sketch here. You've got somebody standing on a platform. They're shooting an arrow. That arrow is going up and coming back down. Okay? And so if you wanted the highest point, would you want standard form, vertex form, or factored form? Well, the highest point would be called a maximum, but another word for that would be vertex. You're looking for the vertex there. So I'm going to lean towards B. And then if I'm looking at that, I want you to think about what those numbers are trying to tell me in terms of the story and what that highest point would reach in terms of feet. What is the max number of feet that the arrow reaches? Well, the next one says, well, how long did the arrow take to reach the highest point? So it's still talking about the highest point. That's still talking about the vertex. The first question is really wanting to know about feet. That's more distance. But how long did it take? That's more time. So I want you to think about, using function b, what numbers should go in those blanks to kind of answer those questions. 15, how long, question about time, how long does it take the arrow to reach the ground? So if I'm thinking about when it hits the ground, which of these forms really talk about this x-axis where it hits this particular place? And hopefully you're thinking about factored form. Factored form would be equation C. And so if I set each of these equal to 0, which of these numbers will tell me how long it takes to reach the ground? So think about the third one, C, and think about how many seconds it's going to take for it to hit the ground there. Well, 16 says, what's the y-intercept in the function? Well, that's more standard form. Standard form can tell you if it's facing up or down, but it can also tell you what the y-intercept is. So I think I'm going to use function A there. Now, I've got a little picture here for you. I want you to tell me what the y-intercept is. And if you're thinking about the story about the archer, like, what does the C mean when you know that number? Okay? We'll answer those together in class. Hopefully, when you're looking at this, just checking my time, I got about a minute and a half. Which of the following is in vertex form? So some of these are in vertex form, factored form, standard form. I want you to pick the one that's in the correct form, that is vertex. 18 says, does this open up or down? So that means if you're looking at this equation, does it do this? Or is it more to the right? Or is it more to the left? Now, I'll be honest with you, we ain't really done any of those. Okay, so it's probably either up or down. You can open to the right if you're doing square roots, but this isn't a radical function. This is a U-graph parabola that's either up or down. And in this last section, I want you to really think about how to solve these. I want to keep us sharp in terms of solving for x before our next test. So I want you to think about factoring to solve, quadratic formula to solve, square rooting to solve. Those are all methods that we've been talking about. And so I really just want you to show me what you understand with that. Thank you so much for watching the video, and I'll see you tomorrow.